Welcome to our series on relations, and we're going to continue on in this video and talk about conducting an experiment and basically trying to give you some sense of dependent and independent variables. So when you're conducting an experiment, remember that with respect to relations, we want to be able to try to create some kind of a hypothesis that we want to see if it's true or false. And we want to be able to collect the data either through covering the entire population or through some sampling method that we have. And we talked about those sampling methods in previous videos, and I'll try to link them towards the notes as well for you. And once we kind of collect all our data, we have to remember that ultimately we are trying to solve some kind of a goal, right? So what is our ultimate goal in an experiment that we have? And we can have many different experiments, right? So let's, for instance, say that we wanted to see if our heart rate is impacted by, let's say, maybe our fitness levels of some kind, right? And for that, we would have to create some kind of a hypothesis to say, okay, and structure our experiment in some way. Now, there are several things that we have to actually run a full experiment that you should be aware of. So let's maybe outline those first. So if you're going to run some kind of a test to try to see or prove or disprove some hypothesis, a guess that you've made, you basically will always pretty much start off with having some kind of a goal in mind. Now, what is the ultimate goal that you want, right, in your experiment? Why are you doing this, right? What is your interest or what is your objective that you have for this particular experiment? We don't do just experiments, okay, in sciences, in business, engineering, anywhere else for that matter. And just for no goal at all. Even if we're doing things for fun, we typically want to try to find something out. So that's kind of the number one thing. What is our ultimate goal that we want? And once we know what our ultimate goal is, then from that, we want to be able to create our hypothesis. Now, remember, a hypothesis is very specific. So when I say it's specific, it has to be structured in some way that you can basically collect data, right, through some sampling method or through a census, so meaning the entire population, so surveying everybody, and being able to answer that hypothesis, it's true or it's not. So when I said, for instance, your heart rate, so let's say maybe your resting heart rate, is it impacted by your fitness levels that you have? That's not a hypothesis, right? We would have to structure it in a very specific way in order to run some kind of a data sampling on that. So for instance, we can say, for the age group of, for instance, 20-year-olds, okay, my hypothesis is that for that age group, your fitness level, okay, will show that your resting heart rate decreases, okay, relative to that fitness level. And we can answer that if it's true or not. And I said 20-year-olds. So we can take 20-year-olds, and then obviously to get the entire population of 20-year-olds would be very difficult. So we could make it very specific and saying that, let's say maybe it is in your high school or in grade 9. And then we can create some sampling methods, so either simple random sampling or systematic sampling or stratified sampling of some kind that we talked about in the previous video. I'll link that up above so you know those sampling methods. And then we can just answer this particular hypothesis, okay? Now, when we have such a hypothesis, obviously, as I said, we need to be able to collect our data. So we have data collection. And in that data collection, you're going to be asking yourself, can you possibly, survey the entire population, or are you going to be using some kind of a sampling method, of your choice? Now, and is it going to be random, or you're not going to be making it random? So meaning that it would be a biased sampling. So how do we collect this data is up to you. Are you going to be the primary collector of the data, or are you going to seek out information in the secondary data collection and maybe take it out of some past research or something that somebody has done? So now, after this data collection, right, what you're going to run into is, you're going to have to set up, in that data collection, and this is important, you're going to have your dependent and independent variables. Let me copy this down here. So copy, let me paste it here. So when you're doing that data collection, and let's say I'm going to go back to that levels of fitness and your resting heart rate that you have. And then, so your level of fitness that you would have, is now, all right, is it a dependent or is it an independent variable that we have? What even is dependent and independent? What does that actually mean? So I'm going to talk about that just after I finish this whole process of running an experiment. So far, when we run an experiment, we have some kind of a goal or an objective to find something out. We create a hypothesis which we want to be able to prove if it's true or if it's false. Then we start with data collecting, and then we have a data collection and we ask ourselves, all right, are we going to be the primary data collectors, or are we going to seek out secondary data collectors where somebody else does that collection for us? All right. Now, and are we going to be doing the entire population, or are we going to be doing some kind of a sampling method, right? So typically it will be some kind of a sampling method, because as I mentioned before in the previous video, those sampling methods, allow you to scale down so that you can actually capture some data collection, because it's very difficult to do the entire population, unless maybe you're interested just simply in doing, your class in particular, right? So after this data collection, what happens? Well, what happens is that we can take the data collection and we typically would plot it out, or we would put it in a table or in a computer in a sheet, maybe some kind of a spreadsheet of some kind. And then we're going to start doing observations, right? We're going to be able to see, okay, with this, what can we observe? What can we take out? Can we actually prove or disprove our hypothesis, right? Do we have to change anything around? So here, the next step is observations. So those observations that we take, hopefully are going to give us some kind of a conclusion that we can base our answer and then, finally answer this hypothesis and hopefully, get to our goal or objective of the experiment, why we even started this. So we would have some conclusions. Now, conclusion, when you have a set of data, so this is typically, or maybe called, an inference. So here, so inference, so this is a nice keyword, especially when you are talking about data collection and then doing observations and conclusions, because inference means that you have already collected some data and you are inferring to that data, you're going back to it and then making conclusions out of it. All right, so the two words can kind of be interchangeable, except an inference is, very specific to your collection of data and your experiment. All right, now finally, you hopefully will get to the point where you can do some final reflections on your experiments. and see if you can actually do any improvements, right? Because nothing typically is perfect. You know, you can question your experiments. You can also get some idea from others. So typically, if you're a scientist, you know, you may want to reach out. You will probably maybe publish your results or something of that nature, and then see, you know, if there's people can kind of find out any flaws in it, so then you can do improvements in your overall experiment and maybe retry it again. Okay, so let me zoom out here a little bit so that you can see all the points. This basically is how you conduct an experiment. You know, you start off with certain goals or objectives, you go through your hypothesis, you know, you're collecting your data. So that is related to the population or the sample, okay, population that you have. And, you know, you make certain observations from that data, and then you can create your conclusions. And then finally, at the end, you can kind of reflect and see if you can do any improvements. So that's how you would run an experiment. And in math, very often what's forgotten, because, you know, we see all these numbers, we see all these variables like x's and y's and z's or whatever it may be, people really forget that all of that is actually related typically to some experiments, to something which is real. It's not just some numbers flowing around and they don't mean anything, right? So there is something that math does. Math is a tool to be able to apply it to problems or goals and objectives that we have, as I mentioned right here. So remember that we have a goal or an objective ultimately. You just don't want to do numbers just for the sake of numbers. I mean, unless, you know, that's what you fancy or something like that. So now let me go back and talk here about this dependent and independent variables, because this is a tricky thing, especially for anybody who's kind of starting off. So let me end this right there and then paste back here this dependent and independent, okay? And I'm gonna write here as well variables. Now, what does this word variable actually even mean? Okay, so this is also tricky, and sometimes, you know, I like to write it as a quantity. So dependent and independent quantity or quantities. Now, quantity is something that we can measure, right? So we can put a number on it. So some quantities is, for example, time. So time we can measure. We can measure definitely our age, which is basically time, right? We can measure mass. We can measure our mass or our weight. We can measure the speed of a car, right? We can measure the distance that we traveled. We can measure the heart rate. So we can measure how many beats we have per minute. So that would be a quantity, right? We can measure the pressure. We can measure the income that somebody makes. We can measure the hourly rate, okay, that you have. So these are quantities. But in math, okay, so those quantities, that mass, the volume, okay, and so on, typically, you know, we refer to those as variables. It is just some, typically it would be some letter, right, that you have, like an X or a Y or an M. But remember that those things have a meaning. So when you say an M, you know, maybe you are referring to mass. You know, maybe capital V, you're referring to volume. So those variables are really just quantities that we can measure. Okay, so keep that in mind, that these variables are things that we can actually kind of measure and we can quantify. We can put numbers to them. So now, what's the difference between dependent and independent? You know, if you're a student, you know, you're most likely a dependent, right? You're depending on your parents or your guardians or somebody else that will kind of take care of you. Now, I know that people in high school or, you know, elementary school or something, as you're growing up, you know, you think that sometimes you're kind of like, I don't really need my parents or guardians or somebody to help me. But at the end of the day, you're dependent on them, right? You know, they will typically provide you with some kind of a house or apartment or something. You know, you have a room or bed to sleep in. You have, you know, food to take in. You're not an independent where you basically can just take care of yourself entirely and you know, if your parents or guardians are not around, right, okay, you can do everything on your own. Now, even parents or adults in general will kind of be dependent at some point, right, on others as well to try to help them along. So, you know, that dependence in terms of trying to understand what it is, okay, you should know that, like, all right, if it's dependent, that means it is impacted by something else, right? And independent means that typically it will not get impacted at all, right? Or it is impacting something else. So in math, okay, so if you have this dependent and independent, so let me maybe try the best I can here, and you can put comments if you like, or so that I can answer them and follow up with you. Okay, and let's try to explain this a little bit, maybe in terms of a definition. So dependent in this context of, you know, doing relations, meaning kind of data sampling and so on, and collecting data. Okay, so what that typically means is, remember that these, you know, are variables, right? So there's those quantities, mass and volume and pressure and heart rate. So that's what we mean. And what we have is, okay, so these variables, okay, so a dependent variable, okay, is impacted by another variable. So the word impacted is, you know, kind of a synonym, I guess, for being dependent. Okay, so it is impacted by something else. And an independent variable, so an independent variable, independent, okay, so this is a variable, okay, again in our context, variable that has an impact on another variable. So if we go back, okay, to this concept where I was talking about, you know, your fitness levels and then your resting heart rate, let's say for a 20-year-old. So, you know, your fitness level that you would have, depending how you structure that fitness level, okay, and you can maybe measure it in some way. Okay, so based on, let's say, you know, for instance, the distance that you cover, okay, in terms of running, you know, without stopping, or maybe the time that you have, you know, you can take a kind of a trial run. Let's say, you know, you'll do a 1 kilometer run, and then you'll see, okay, how quickly can you cover that? And, you know, so that could be your gauge of your fitness level, or maybe something else. And now you want to see if that, okay, will impact the actual resting heart rate of that person. Now, my guess is, I guess from the things is I am a little bit of a fitness junkie. So, you know, the more fit that you are, okay, you know, your resting heart rate will typically be lower, right? Because you have trained your heart, okay, to be able to work at much higher, okay, kind of fitness levels. And then when it's resting, okay, it doesn't have to work as hard, right? While somebody else, okay, who maybe isn't as fit, okay, their resting heart rate might actually be a little bit higher because they haven't trained it. It's kind of like a muscle that you have, right? So it gets better over time. So in that sense, you know, your independent variable maybe would be your fitness level. And then your dependent variable would actually be your heart rate that you have. And what we like to do in math, okay, and I will write here, so for example, your independent variable, and I'll call it X, okay, and that's what you typically see in math. And your dependent variable, I'll call it Y, all right? Now, sometimes if you start studying, you know, functions, okay, which is not in this particular way, because this is kind of grade 9 material, you might write Y as simply f of x, okay, and you sometimes will see it as this, okay, and that is kind of like your Y, because that's saying that your function is being dependent on this x, right? So your fitness level is basically what is going to be the independent variable, and then your heart rate is going to be your dependent variable. And if you would be drawing this, okay, and you have, so since we're going to be drawing some plots in a future video, okay, so if we have our plot like this, okay, so you typically will see that, and your x is always kind of on the horizontal, and that is your independent variable that you have. That's what we place here when we do our data collections, so independent. And this, you know, as I said, maybe is your fitness level, right? So fitness level, okay, and somebody can provide you those fitness levels, or you can decide on what that would be, okay? So maybe on the times that you have for a 1 kilometer run. And then here, this would be y, okay, and that is your dependent variable, okay, so dependent variable. And this, you know, for example, could be your heart rate. And now we can start plotting things up, okay, but we'll do that in the next video. So these dependent and independent that we run into, they're not very easy to be able to pick off, and it does take a little bit of time to try to gauge these, right? Which one is dependent, which one is really independent. And it will also be dependent on what your goals, objectives, and what your hypothesis actually is, right? So depending on how you state these things, it will really decide, all right, what is being dependent and what is independent in terms of the variables that you carry. So for this, okay, so I'm going to give you a few examples, okay, to finish off this video. You know, we have heart rate and fitness, so I gave you one. But what if, for example, you know, you were doing something and you had age, okay, and let's say, you know, make it fun, sticking with the fitness, and the number of push-ups that you could do, right? And both of these, notice these variables, so we can certainly measure somebody's age, right, how old they are, and we can definitely measure how many push-ups, okay, that you can do. So now, which one would be dependent and which one would be independent, right, in terms of this? That will, okay, of course, depend on the actual hypothesis that you have, right, like what's a little bit more information. But you can hopefully see a little bit, you know, that your age, okay, most likely will be your independent variable, right? Where your age will impact the number of push-ups that you could possibly do. So this would be your Y, which is your independent, right? And that's the number of push-ups that you have, right? Here is another example that you may run into. Okay, so let's say, you know, your level of education. This is one of my favorites. Okay, so level of education, and for instance, the number of books that you read. So the number of books, okay, that you read, let's say in 1 year, right? So again, you can decide, all right, so which one is dependent and which one is independent? Okay, so what do you think? You can kind of think out loud, you know, so for this one, I would most likely say, okay, so that the independent, okay, variable is your level of education, and your dependent variable will be the number of books that you read. Okay, so that's one. And notice it's not very easy to kind of tell dependent or independent, okay, and you do have to do a little bit of work on these and try these out. Okay, so here is another one for you, okay, in terms of, okay, so something, for example, let's say we have car range. So car range, now that we're getting more and more into electric cars, so car range, so how far you can go, and battery size. All right. So which one would be dependent and which one would be independent? And you may have to know a little bit about, you know, electric cars, okay, so in terms of car range and battery size, but intuitively you should kind of know, right? you know, because you have all kinds of devices, and you know that, you know, the better the battery, the longer it lasts, right? So here, you know, I would say that this would be my independent variable, right? So the battery size. And the dependent variable, so the car range depends on the size of the battery, and that would be your Y. So these are some examples that you have, and you can come up, and I encourage, you know, you guys to start putting some of these up and start thinking on your own, all right, about this dependent and independent. And that's all that I wanted to present in this particular video. So hopefully it introduces you to the concept of conducting an experiment, which we have outlined here. Let me zoom out a bit. So from your goal and objectives, going into your hypothesis, data collections, and then observations and making conclusions. So we'll try to do that in a future video. And here, you know, I've also introduced the dependent and independent variables. So again, remember that dependent simply means that it is impacted by something else, okay? So another variable has an impact on it. And independent, okay, is the variable that has an impact on another variable, right? So that's what you have. And these variables are quantities that we can possibly measure. And I said mass, volume, pressure, you know, heart rate, your age, okay, battery size. All right, so we can measure all of these different things, okay, and those are variables in math terms that we call, okay, so those variables we typically allocate some kind of a letter or a symbol like X and Y. All right, so moving forward, you hopefully will know that these X's and Y's in math, they actually have a meaning, right? They represent something, but we typically forget about that. All right, so thank you for watching. I hope that you find this useful. You know, hit a thumbs up, okay, if you liked it. If you have some questions, you can put them in the comments, and I'll try to follow up the best I can. All right, bye, everybody. Cheers.